Hello everyone. Today I am going to explain about one problem on two-port network parameters. In this one, here we have to find out the open circuit impedance parameters for the following network. So this network is called as a bridge T network. So in this one, here we have to find out what are the open circuit impedance parameters and determine whether the network is symmetrical or reciprocal. So let's consider this network. So this network is called as a bridge T network. So it has a two ports, 111 dash 22 dash. So for 111 dash, so the current it is I1 and the voltage it is V1. For 22 dash T, the current it is I2, the voltage it is V2. So in this one, here we have the three currents. One is I1 current in this mesh 1. Here it is I2 current in the mesh 2. In the mesh 3 it is I3 current. This is your intermediate current. So here we will get a intermediate current value in terms of I1 and I2. So here we have to find out the Z parameters, which are called as open circuit impedance parameters. So the Z parameters equations are in terms of V1 and V2. So these are the dependent variables. These V1 and V2 depends upon the I1 and I2 variables. Here I1 and I2 are nothing but your independent variables. So the voltage equations in the open voltage equations for open circuit impedance parameters are V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. Here we have to find out the Z11, Z12, Z21, Z22. Okay, for this purpose I am redrawing the circuit again here. So redraw the circuit and mention all the currents here. So in this one, for mesh 1 it is I1 current, for mesh 2 it is I2 current, for mesh 3 it is, and let us assume it is an intermediate current. You can take any value. Here I am assuming it as a IX current. So for this purpose, for this one, to find out the Z parameters, I am applying a KVL, or you can apply also by applying a KCL also will get that values. So here I am applying a KVL to mesh 1. So this is your mesh 1 now. So V1 is equal to I1 1 into I1 minus of Ix value. Here it is I1 is your entering current. Here Ix is in opposite to this current. So it is I1 minus of Ix plus 2 into I1. Here I1 is your entering current. I2 is also your entering current. So you will get a 2 into I1 plus I2. So therefore the mesh equation V1 is equal to 1 into I1 minus of Ix plus 2 into I1 plus I2. So upon solving this, we will get a V1 is equal to I1 minus of Ix plus 2 I1 plus 2 I2. So therefore we are getting here V1 is equal to 3 I1 plus 2 I2 minus of Ix. So in generally the Z parameters equation is V1 in terms of I1 and I2. Here we have the extra one more term, that is Ix. Okay, we'll solve it by applying a KVL to mesh 3. So apply KVL to mesh 3. So mesh 3 is nothing but this is the mesh 3. So here it is. Let us assume this current as Ix current. So the total voltage across it is 0. So 0 is equal to 4 into Ix plus 3 into here the Ix, and here it is I2 is also entering current, Ix is also entering current. So here we will get 3 into Ix plus I2 plus here again in this 1 ohm resistor, Ix is your entering current, I1 is your exit current. So we will get Ix minus of I1. Therefore this mesh 3 is equal to 4Ix plus 3 of Ix plus I2 plus 1 into Ix minus of I1. So upon elaborating this value, we will get a 4x1 plus 3ix, 4ix plus 3ix plus ix means we will get a 8ix plus 8ix plus, here we are getting a 3i2 minus I1 is equal to 0. So from this one we have to find out the Ix current now. So Ix is equal to 1 by 8 I1 minus of 3 by 8 I2. Now substitute this Ix value in the equation number 1, because in the equation number 1 we have the 3i1 plus 2i2 minus of ix. Substitute ix value here. So here we will get v1 is equal to 3i1 plus 2i2 minus of ix. So minus of ix, now substitute ix value as 1 by 8 i1 minus 3 by 8 i2 here. So you will get here 3i1 minus 1 by 8 i1 plus 2i2 here minus into minus na. So here you will get a plus of 3 by 8. So here v1 is equal to 3i1 minus 1 by 8 i1 plus 2i2 plus 3 by i2. So take down the i1 term as common. Here we will get a 3 minus of 1 by 8 plus i2 of 2 plus 3 by 8. So upon solving this we will get a v1 is equal to 2 by 3 8 i1 plus 19 by 8 i2. Okay. So this is the v1 equation, open circuited voltage equation in terms of I1 and I2. So from here we can say it is Z11 I1, Z12 I2. So it is Z11 is equal to 23 by 8, Z22 is equal to 19 by 8. Similarly, apply a KVL to this mesh 2. So apply KVL to this mesh 2 means this voltage V2 is equal to the drop across this 3 ohms resistor. This 3 ohms resistor is consist of I2 current as well as Ix current. So in this both currents are entering, so V2 is equal to 3 into I2 plus Ix plus this 2 ohms resistor into here 2 ohms resistor is also I2 is entering and I1 is entering. So therefore here V2 will get 3 into I2 plus Ix plus 2 into I2 plus I1. Upon solving this, we will get the V2 is equal to 2I1 plus 5I2 plus 3Ix. So here again we are getting a one more term Ix term. So to remove this, I am simply substituting Ix is equal to 1 by 8 I1 minus 3 by I2 in the equation number 2. Therefore, we will get a V2 equation is equal to 2I1 plus 5I2 plus 3 into Ix. So simply substitute Ix value as 1 by 8 I1 minus 3 by 8 I2. So here we will get 2I1 term plus 3 by 8 I1. So take down the I1 term as common. Here you will get 2 plus 3 by 8. So take down the LCM. So it's 16 plus 3, 19 by 8. You will get the term here 19 by 8 of I1. Similarly, here take down the I2 term as common. 5I2 minus 3 into 3 by 8 means 9 by 8. So for 5 minus of 9 by 8. Here you will get a 40 minus 9, 31 by 8 into I2. So this V2 equation is in the form of a I1 and I2 and nothing but Z21 I1 plus Z22 I2. But upon just compare this V1 and V2 equations with the Z parameters equations. Okay, so from here we can say that Z11 is equal to 23 by 8 and Z12 is 19 by 8, Z21 is 19 by 8, Z22 is 31 by 8. Okay. So by this is way we have to solve this open circuited impedance parameters, and in the question what they are asking, determine whether the network is symmetrical or reciprocal. So we know if the network is symmetrical means we have to get the Z11 value is equal to Z22, then only we can say the given network is symmetrical. Here we are getting Z11 as 23 by 8, Z22 as 31 by 8. So both are not equal, so the given system is not a symmetrical network. Similarly, what they are asking here, find out whether it is a reciprocal network or not. So if any network is reciprocal, the means Z12 is equal to Z21. Here we are getting a Z12 as 19 by 8, Z21 as 19 by 8. So the given system is reciprocal. So it is Z11 is equal to 23 by 8, Z22 is 31 by 8. Both are not equal. So the given system is not a symmetrical network, asymmetrical network. And to check down the condition for reciprocal, simply take down the Z12 value, Z21 value, 19 by 8. It is also 19 by 8. Both are same now, since the given network is a reciprocal network. Thank you.